Okay, and today we're actually going to start with the bell ringer. And with the bell ringer recap, just remember when you're counting atoms, you multiply everything inside times the subscript, and later you multiply everything by the coefficient. We will practice more of these on the board. Okay, so today our big focus is how to balance equations. Remember, things to the left are your reactants, things to the right are your products. And the key thing is you have to make sure that both you have the same amount of one type of element on the left side as you do on the right side. The first thing you do is you actually count the elements present on both sides of the equation. And then actually what we're going to do is write the total amounts underneath, down below in the space, and actually count the atoms and write them down below each one so we know how much is on each side. If we don't have enough, basically what we add are coefficients, those big numbers in front of each element or compounds in the formula or in the equation, right in front of a formula. We recount again to make sure that we have it balanced. Okay, so let's start with this one. Let me get my pen working. And I'm going to use green here. The first thing I always do is on the arrow draw a line, and I'm separating the left side from the right side. Over here I count my Cus, which are coppers, and I have 1 copper, and then I count my oxygens, and I have 2 oxygens. Okay, now on the right side I'm counting, I have 1 copper and 1 oxygen. Well, as I see it, my coppers are both balanced on both sides, 1 and 1. They have the same amount, so we're good. But look at this, my oxygens are not balanced. I have 2 on the left and 1 on the right. So what I do is I take my lower number over here, 1, and I ask myself, what can I multiply times 1 to give me 2 so it'll balance over here? And it's actually a 2. So we're going to write a big coefficient in front of the whole compound. So now I'm going to draw a line through both of these, and I'm going to recount my atoms. 2 times the 1 copper gives me 2 atoms of copper, and 2 times 1 oxygen gives me 2 oxygens. Well, now my oxygens are balanced, but now my coppers are not. I have 2 over here, 1 over here. So I go to the lower value, the 1, and I ask myself, what can I multiply times 1 to give me this number 2 over here? And again, multiply it times 2. 2 times 1 gives me 2. Check to make sure. 2 coppers to 2 coppers, 2 oxygens to 2 oxygens. This makes it balanced. Now I can leave it blank in front of the O2, or I could theoretically put a 1 to represent I need 1 atom of the oxygen, or one component of that oxygen. Okay, let's look at this one right here. Again, I'm going to draw my line, get my pen, and I'm actually going to use red this time. I'm going to draw my line down the equation. I'm going to count my atoms. I have 2 nitrogens, 4 hydrogens, 2 oxygens, 2 nitrogens, 2 hydrogens, and 1 oxygen. So when I go through this one, I have 2 nitrogens to 2 nitrogens, 4 hydrogens to 2 hydrogens, 2 oxygens to 1 oxygen. So I know my oxygens are not balanced, but also my hydrogens aren't. So if I put a 2 in front of this, okay, 2 times 2 gives me 4, okay? And I'll explain this on the board again. But I have 4 hydrogens over here to the 4 hydrogens. That makes it balanced. And putting also that 2 in front of the coefficient, in front of the water molecule here, 2 times the 1 oxygen gives me 2. Okay? So 2 oxygens here, 2 oxygens here. They're balanced. 2 nitrogens to 2 nitrogens. This is balanced. I could leave it blank, or I could just put a 1 in front of it, and it would be fine to show that it's balanced. Okay, let's look at this one. Okay, whoops, let me go forward. Sorry. Let me change my pen color again. I'm going to keep it red again. That seemed to show up. All right, so I have over here, I'm counting 1 potassium, 1 chlorine. See that? That's a lowercase l, and 3 oxygens. Okay. I have 1 potassium, 1 chlorine, and 2 oxygens. Well, when I look at this, my potassiums and my chlorines are both balanced, but my oxygens are not. Well, I know 2 can't go into 3 and 3 can't go into 2, so I think, what common number can both 2 and 3 go into? And then I think of 6. Okay, so I got to ask myself, what can I multiply times 2 to give me 6? And the answer would be 3. Okay, so 3 times 2 is 6. Then over here, I have a 3 as well. So I got to ask myself, what can I multiply times 3 to give me 6? Because this is what I want as my common multiple. 6 is my common multiple. And 2. Put a 2 in front. So 2 times 3 gives me 6. But look what it also does. 2 times 1 gives me 2 potassiums, and it also gives me 2 chlorines. Okay, now my oxygens are balanced, but my potassium and chlorines aren't. So I got 2 on this side, 1 on this side. So what can I multiply times 1 to give me 2? And that answer is 2. All right, so 2 times 1 is 2. And 2 times 1 is 2 as well. Oops, let me get this written. Oops, sorry. There we go. So now I have a balanced equation where 2 is in front of this compound, 2 is in front of this compound, and a 3 is in front of this one. Okay? Now, what we need to do now on this one is identify the balanced equation. So some of the past questions have been on the test, have been like identifying a balanced equation. When I look at the first one, there's 1K to 1K, 1Cl to 1Cl, only 2 oxygens, and look at that, 2 times 2 is 4. That one's not balanced. All right, I have 4 aluminums, and I have 4 aluminums. Look at this. Take it element by element. 4 on this side, 4 on that side. 2 times 2 is 4. I have 6 oxygens. 2 times 3 is 6. So this one would be balanced. The second one would be balanced. First one's unbalanced. The second one's balanced. Now at your seats, try the third, the fourth, and the fifth. Okay. Make sure, let me come back, make sure you pause, check it, raise your hand, and let me know if you need any questions with balancing equations. Okay, so why balance? Well, there's this law, and it's called the law of conservation of matter. And it said that matter, we can't create it, but we also can't destroy it. What happens is one form changes into another form. Like if you mix some liquids, it might turn into a form of a gas, and we may not see it, but it's out there, it's somewhere. So the key thing is this is the law called the law of conservation of matter. Okay, where matter can neither be created nor destroyed. What you start with should be theoretically what we end up with. Okay? Any questions for today, please ask, and we will go over how to balance equations. Thank you.